Hello. Okay, so thank you everyone for joining me today in the NASA Hype Award, and it's my pleasure to present my study. So focus on the robustness of some common precipitation product for Vietnam River Basin. So my name is Duc Tran. I'm from University of Virginia. I'm a second year PhD student. Please look to the top right hand side. So we can see that the storm with the 60.2% that has been recognized one of the most occurrence natural hazards happened in Vietnam between 1980 and 2020. So one of the very current and very famous tropical storm called Linh Pha happened between the 6th and the 10th 2020. Significantly damaged to the central Vietnam. And so in this study, I have evaluated some different common and freely accessible satellite precipitation product over 7 different climate regions, covered a total of 11 river basins, so from the north to the south. But please notice to the S5 river basin, which represent to the tropical cyclones region, and the this river basin does represent for the semi-arid region. And so moves to the second part of this presentation, that we have to look at some chosen precipitation products that we use in this study. So I want to highlight here only one product that very renowned, and maybe most of people here knows about that, which is global precipitation model, GBM image, that has been used in 1,000 publications and study to monitor the near real-time global precipitations or capture extreme events like the Hurricane Matthew over Haiti, and also to monitor the El Nino event. And so along with GBM image that has been used in this study, I also use the other products called MS Web, which is one of the very famous products used as the reference to evaluate so many different satellite precipitation products. And also one of the, please look to the right hand side, we see the SM Terrain ASCAT, which use the SM Terrain algorithm that's called soil moisture to rain. That's use the ASCAT soil moisture data collected from ASCAT satellite. And the next one is the CHUBS, one of the very famous one used for the drought monitoring and detections. The next one is Basins CDR. That's one of the U.S. institutions-based precipitation product. That's use the gauge data for bias corrections, and also the last one is Aphrodite, one of the very, very famous Japanese products. Okay, so here's the first part of the result and discussions, and you please see to the right hand side. That's the first thing that I have done is the intercomparisons of all of these products against the rain gauge data, and I use the entire 6 different indices, which is the PRD that's represent for probability of detections. 4 is the for alarm radio. CSI is the critical success index, RV's relative bias, root mean square errors, RMSE, and also the last one is correlations coefficients. And we can see that I have ranked these products, which is the top and second and the third. That's represent the first, second, and the third best products. While the Basins CDR that shows the lowest performance over indices, and also in different basins. And one of the key point here. So usually we know that many studies indicated the CHUBS as one of the best products for drought monitoring and detection, because I mentioned here because I think that most of the people here, they're also dealing with drought study right now. But in this study, over 11 basins, I found that the SM Terrain ASCAT show even the lower root mean square error. That means that this product is show very high potential to be used for drought monitoring and detection in recent event. For your information, my lab right now, the HydroSand Research Group, we are developing the newest very high resolution 400-meter SMAP soil moisture data. So for those who are interested in doing this path, please refer to our research group for this data set for your study. And along with that, we also look at the stream flow data. So this figure on the left-hand side does represent the first, the second, and the third ranked products. That obviously that drain gauge were ranked as the best product, but follows by GBM IMUSH and MS Web. But we think that that's better to also look at the flood peak, because usually traditionally people look at the stream flow data, but I think that's not needed. So to do that, we look at the flood peak data, and I have first categorized these 11 basins into 3 different levels of basin size, with these small basin size that represent below 1,000 kilometers square. Medium is between 1,000 and 4,000 kilometers square, and the large is more than 4,000 kilometers square. And the results show that GBM IMUSH were ranked the second best after rain gauge against the observation data, with only 1 to 2 basins that show the underestimation. That's might caused by the reservoir and dam impact, while the MS Web follow closely, but show the higher underestimations over different basin size. And we also using the NASA clip efficiency and presented by us to rank how the simulated stream flow look like over different basins against the rain gauge and observation data. And we can see that from the top to the bottom, that's why GBM IMUSH, MS Web, and soil moisture terrain ASCAT were ranked as the first, the second, and the third best product. Best consider were found as the poorest performance. And also, we try to look at whether different products that uniformly perform in different basin size and different climate region, using the formula shows on the presentation, and also combined with the elevation drain and the rain gauge density, we found that why GBM IMUSH shows the best products, followed by MS Web and SM Terrain. The Aphrodite and best consider differ over basin performances. So in general, we can say that GBM IMUSH is very reliable for hydrological modeling and also for extreme event detections. And this one is the last one, and also the most interesting slide that I want to thanks to NASA and also other institutions to provide access for my study, and also special thanks to Professor Dr. Venkatlasmi and other colleagues from University of Virginia and NASA Goto that support me during the presentation of this work. And one last step. NASA just recently launched their very interesting missions that calls SWOT. So survey water and ocean topography that allow hydrologic and researcher to capture the water gains or loss in the wetland, lake, and reservoir, and also the discharge variation over river globally. So please look for it. It's very interesting. Thank you very much.